What is up everyone, my name is Kingsley. Today we are going to present about our findings on an energy that might kill and save the world at the same time, the nuclear energy. But before that, let me just briefly tell you how does a nuclear power plant works. A nuclear power plant is a thermal power station that generates electricity using heat. The process of energy transformation is from chemical energy to thermal energy, kinetic energy, mechanical energy, and finally electrical energy. So how does this chain reaction even start? Let's have a look inside the nuclear reactor. This whole chain reactions all starts with the element called uranium. Uranium is mined from the Earth's crust and is not a rare element, more abundant than gold, silver, and mercury. The atomic nucleus of uranium is densely packed with protons and neutrons bounded by a powerful nuclear force. Natural uranium mainly occurs in a mixture of the two isotopes, uranium-238 and uranium-235, but they have huge differences in scale. Only about 0.7% of the abundance of uranium is U-235, and this lighter isotope is less tightly bound. Compared to U-238, a neutron strike easily splits U-235 into smaller and lighter radioactive elements, while releasing 3 neutrons, gamma rays, and energy. A fraction of these energies released will then power the neutrons produced and strike the other U-235 in the reactor, resulting in a chain reaction. These chain reactions are monitored and can be controlled using control rods by absorbing the excess neutrons. There are also moderators such as graphite and purified water to slow down the kinetic energy of neutrons and raise the rate of fission. Also, uranium is needed to be enriched to 5% or more of its abundance in centrifuges. This system separates lighter U-235 from heavier U-238 before it can be used in the reactors. The enriched uranium is then further processed into tiny ceramic pellets and sealed into metal tubes, which are welded to form a fuel bundle. Those fuel bundles will then be inserted into the reactor and the preparation is done.
One of the reasons why nuclear energy is used is because it's the most efficient source in terms of extraction of energy, which is about 8,000 times more efficient than coal or oil. According to the Nuclear Energy Institute (NEI), a fingertip-sized pellet of nuclear fuel contains as much energy as 17,000 cubic feet of natural gas, 1 ton of coal, or 120 gallons of oil.
Another reason is due to climate change caused by carbon emissions from burning fossil fuels. Currently, 84% of the world's primary energy comes from fossil fuels, 33% from oil, 27% from coal and 24% from natural gas. It's a challenge for us to fully replace fossil fuels with renewable energy using the current technology, as they still have their own problems before they can take over the vast majority of the electricity grid. The main problem is reliability and consistency. As countries kick fossil fuels out of their energy grids, nuclear could provide a steady baseload for when the sun's not shining and the wind's not blowing. We need massive storage capacities where we can save energy collected when the sun or wind are at their peak and release it later when we actually need it. Until this is possible, nuclear energy seems to be a better short-term solution to replace fossil fuels compared to the alternatives. Quitting nuclear simply means burning more fossil fuels, which contributes to the global crisis we are currently in. Let's have a look at the comparison between the sources. The construction cost of a coal power plant is lower than hydropower and nuclear power plants. A coal power plant produces electricity by burning coal to boil the water and produce a steam. The steam then flows into a turbine at high pressure to spin the blades. The turbine is connected to the shaft of the generator, which then rotates large magnets within wire coils to generate electricity. The operation cost of coal power plants is the highest compared to the alternatives because huge amounts of coal are needed to run the coal power plant. According to the University of Calgary, a 1,000 megawatt electric rated coal plant uses 9,000 tons of coal per day, which is equivalent to 90 cars with 100 tons. Compared to other power stations, coal power plants also have lower efficiency, which is about 34%. It also contains more carbon than oil and natural gas, resulting in greater volumes of carbon dioxide emissions per unit of electricity generated. For hydroelectric, the construction cost is higher because the construction of a dam and reservoir is expensive. The construction is also time-consuming and requires a large space, as the dam is huge, to reserve a large amount of water. The concept of a hydropower station is about capturing the kinetic energy of falling water to generate electricity. The water is first blocked at the control gate under the reservoir. Then the gate is opened after some time. The water that rushes down the penstock produces a large amount of kinetic energy and spins the turbine connected to a generator. This process converts the kinetic energy of falling water into mechanical energy. Then, the generator converts the mechanical energy into electrical energy. Unlike coal and nuclear power stations, hydropower stations have zero operation costs as water is reusable, and the maintenance cost is also minimal. However, the availability of water is unreliable because it depends on the rainfall. Drought season will make the running of hydropower even more impractical. Nuclear power plants are quite cheap in terms of operation cost compared to coal, as only small amounts of uranium are needed to produce lots of energy. However, it requires the highest construction cost because a nuclear power station is a complex system and requires a lot of skilled engineers for construction to ensure the safety of the power plant and the environment. It also has the highest maintenance costs as highly skilled and specialized staff are required, and the cost of replacing the compartments is high. Moreover, it is also slow to build a new plant. Because of the lack of investment and innovation in the last few decades, the majority of the world's nuclear reactors are pretty old technology, and that's costly to replace. Old reactors are more dangerous and need to be retrofitted to stay safe. The longer their lives are extended beyond their original design, the greater the risk that a piece of old equipment breaks. But the problem is, in most Western countries, building nuclear reactors has become very expensive. So it can take a decade or longer just to finish a power plant. In contrast, countries like South Korea, China, India and Russia are able to build new nuclear reactors comparatively quickly and at a competitive cost. Countries like China have planned to cut emissions to net zero by 2060, and as the demand for energy skyrockets, nuclear energy is the only solution. Therefore, most new plants are popping up in Asia as the current generation of nuclear power plants in the West are more expensive to build and maintain than most fossil fuel alternatives. A coal power plant is usually located at a site where coal, water and transportation are available easily. They are usually located near the city, and this is where health issues are concerned. A hydropower plant is usually located where the site accommodates a large catchment area and a steeper gradient. Besides, meteorologists also investigate the annual rainfall throughout the year of that particular location before building the plant. Nuclear power plants are also usually located near water sources because water acts as a cooling agent to cool down the nuclear reactor. It is also usually away from the cities to lower the impact of accidents such as radioactive leakage and meltdowns. Coal-fired power stations emit over 10 gigatons of carbon dioxide each year, which is about 1/5 of the world's greenhouse gas emission. Burning of coal produces smoke, ash, and greenhouse gases that cause global warming and climate change. This will directly cause disruption to the natural ecosystem, and extinction of species might occur in the later stage. Global warming will also cause the melting of glaciers, and indirectly cause the rise in seawater level, threatening nations and islands at the lower altitude. It's like a chain reaction in a nuclear reactor, and it all starts from the greenhouse gases. Hydropower, on the other hand, does a better job of protecting the environment. Although several recent studies state the release of methane gas is detected because organic matters that are trapped in the reservoirs will eventually decay. Not to mention, the carbon dioxide produced due to the large quantities of cement used during construction will contribute to the release of greenhouse gases. However, its greenhouse gas emission is still lower compared to coal-fired power stations. The only concern is that damming the water will cause riverside habitats to disappear, which threatens the aquatic life in that area. Nuclear energy offers almost no greenhouse gas emissions during operation. It produces about the same amount of carbon dioxide equivalent emissions per unit of electricity as wind. Nuclear energy produces the most energy and has minimal pollution to the environment during operation compared to the alternatives, but the fission byproducts it produces after the process is what concerns environmentalists until now. If there is a leakage of wastes or accidents, it might cause mutation to the species nearby and destroy the ecosystem. In this chart, we can see the number of deaths caused by coal is 9.11 million in total, which is about 774 times the total number of deaths caused by nuclear energy. In 2013, a study conducted by NASA found that nuclear energy prevented around 1.8 million deaths between 1976 and 2009. Although we know nuclear wastes are very toxic and harmful, they are usually stored somewhere, while the harmful gases of fossil fuels are directly pumped into the air. People who inhale them can cause respiratory disease such as lung cancer, and in the long term, fatality may occur. By just reducing the amount of fossil fuels burned, countless cases of cancer and lung diseases can be avoided. Nuclear energy sounds more dangerous in our mindset, while fossil fuels kill silently. In a nuclear power station, there are three main issues that people are worrying about, which are natural disasters and safety issues, nuclear wastes and pollution, and nuclear weapons proliferation. As nuclear power plants are mostly built along coastal areas, natural disasters such as tsunamis and earthquakes might happen anytime and damage the nuclear power plant. Once the electricity is cut off and the overwhelming seawater knocks out the emergency generators, failure of the cooling system will cause the temperature in the reactor core to rise dangerously high. This can lead to reactor meltdowns and explosions, causing the radioactive substance to spread into the air, just like the Fukushima's disaster. Safety issues mainly refer to operation mistakes, construction defects, and poor quality of building materials. This will lead to accidents and the leakage of radioactive substances. The Chernobyl accident in 1986 was the result of a flawed reactor design that was operated by inadequately trained personnel. The workers failed to slow down the nuclear reaction, and the temperature in the nuclear core increased drastically, resulting in an explosion of the number 4 reactor. The resulting steam explosions and fires release at least 5% of the radioactive reactor core into the environment, with the deposition of radioactive materials in many parts of Europe. Until today, people were still not allowed to live at Pripyat, as the radioactive substances would take eternity to fully decay. The biggest problem faced by nuclear energy is the toxic wastes it produces. Spent nuclear fuel is not only radioactive but also contains extremely poisonous chemical elements like plutonium. After dumping these wastes into the ocean was banned in 1993. We've tried to bury them. However, there's still great uncertainty about their long-term security. It seems impossible to ask someone to guard plutonium along its half-life of 24,000 years. Another issue that risks the nations and causes public objections to nuclear energy is that nuclear technology has made a violent entrance into the world stage. Plutonium can be extracted from the waste to make destructive bombs. Storing spent fuel is thus not only a safety risk for the environment, but also a security risk for nations. The most common ones in coal power stations are ultra-supercritical technology, USC. They play a role in reducing carbon dioxide emissions and increasing the efficiency of boilers up to 47%, significantly higher than the global average of 34%. Each percentage point improvement in efficiency significantly reduces carbon dioxide emissions by over 2 percentage points, resulting in 26% less carbon dioxide per megawatt than the average coal plant. Combined with advanced emission controlling equipment that can remove local pollutants, such as nitrogen oxide and sulfur dioxide, USC power plants require less coal and produce fewer greenhouse gases. For hydropower, marine and hydrokinetic technology, MHK is the improved one. These devices capture energy from the natural motion of ocean water, such as waves or tides, to generate electricity instead of building huge dams and reservoirs. It has the potential to generate more than 538 terawatt-hours of electricity a year, enough to power millions of homes. There are two fundamental nuclear processes considered for energy production: fission and fusion. The concept of nuclear fusion is by combining small and light nuclei to form a heavier nucleus, while releasing large amounts of energy. The experimental Advanced Superconducting Tokamak East device designed by China has successfully replicated the nuclear fusion process carried out by the Sun at 120 million Celsius for 101 seconds. Unlike fission, nuclear fusion is considered a safer process with no nuclear waste. Nuclear fusion could potentially provide unlimited clean energy at very low costs. But for now, this technology is still unavailable and not commercialized yet. So let's put this aside and look into nuclear fission, which has already been used commonly for about 70 years. We have designs for nuclear reactors that solve many of the conventional reactor problems, namely small modular reactors, SMR. SMR offers a lower initial capital investment and shorter construction duration. It also has a better facility protection system, including barriers that can withstand sabotage, like aircraft crash and natural phenomena hazard scenarios. There are also breeder reactors which produce more fissile materials than they consume, which means they have the ability to make nuclear fuels quite sustainable. The breeding reactions convert non-fissionable U-238 into fissionable plutonium-239, which can be used as a fuel to generate nearly 8 million kilowatt-hours of electricity just by 1 kilogram. However, so far no nation has developed one for high-capacity commercial use. Coal combustion will produce two types of waste, which are solid waste and gas waste. Solid waste such as coal dust and coal soot, and gas waste such as sulfur dioxide and nitrogen oxide will be produced after combustion. It will eventually cause air pollution, like haze and smog. Also water pollution and land pollution, like acid rain that decreases the water quality and causes the soil to be infertile. For nuclear power plants, the classification of nuclear waste determines the priority level of the processing and disposal. Low-level waste is the most common waste type. Anything with small amounts of short-lived radioactivity is classified in this category. It comprises of paper, rags, tools, clothing, filters that are used by people working with nuclear energy. It does not require shielding during handling and transport, but it should be disposed of safely in near-surface facilities instead of being processed with standard trash. Intermediate-level waste is usually the byproducts of nuclear processing, and it is harder to dispose. It typically comprises of chemical sludge and metal covering that have been exposed to radioactivity for a long time, as well as contaminated materials from reactor decommissioning. Due to its higher levels of radioactivity, it requires some shielding to prevent exposure. It may be solidified in concrete or bitumen or mixed with silica sand and vitrified for disposal. High-level waste is the most hazardous one and hardest to dispose. When a nuclear fuel rod serves its purpose and is taken out of the core, it becomes high-level waste. Spent fuel is radioactive and often hot, thus requires cooling and better shielding. Although it is no longer useful for the reactor, it will still remain radioactive and continuously emitting energy for 10 or hundreds of thousands of years. The best way to dispose of these wastes is to put them somewhere isolated forever, but until today, no one has really implemented a viable long-term for nuclear waste storage. There are currently three main options: on-site storage, long-term storage, and reprocessing fuel for use in other nuclear power plants. Reprocessing spent fuel sounds like a perfect solution, but it eventually goes into nuclear weapons. Thus, most experts say the best solution to get rid of the waste is by constructing deep underground facilities and burying it. Unfortunately, the only country that is currently setting up the facility is Finland. Others just store their waste on-site. Most of the nuclear waste is stored in pools of water inside the power plant. Water does a decently good job of shielding radiation, so it's an inexpensive and easy way of storing the rods. The rods will continuously heat up the water, but cooling systems and pumps will keep the water below the boiling point. Once the waste has cooled down in storage pools for 10 to 20 years, it is typically encased in steel or concrete casks. These containers block radiation, but this solution is far from permanent. It cannot withstand disasters, and it requires security and maintenance. If anything goes wrong, leakage of the waste will affect humans' health and pollute the environment consistently. The radiation might cause DNA mutation and malfunctioning of cell repair mechanisms. Prolonged exposure in highly contaminated radiation areas will also eventually cause diseases like leukemia. As a developing country, Malaysia needs to utilize its energy prices in order to increase the rate of economic growth and meet the demands. Energy is one of the most important requirements in developed countries, as the demand for energy is high. Our country mainly relies on fossil fuels and natural gas power stations, and they are not as efficient as nuclear energy. It is more worthwhile to build an expensive nuclear power plant with a cost of around 25 billion to 38 billion ringgits than to sustain the coal power stations, which cost more than 15 billion ringgits per year. Most importantly, nuclear energy provides zero carbon footprints and zero emission of greenhouse gases, which reduce the impact on the environment. This cost-effective energy is more reliable, environmental friendly, and probably safer than you think, as long as we take the waste seriously and plan a long-term storage for it. Although people often worry about the impact of nuclear accidents, like Chernobyl and Fukushima, such accidents can be avoided as our country doesn't have any natural disasters.
Besides, as the technology evolves, newer and more advanced nuclear reactors are invented and introduced. There are already Generation 4 reactors like the Very High Temperature Reactor, which is safer compared to the Generation 2 boiling water reactor in Fukushima and High Power Channel Reactor in Chernobyl. In a nutshell, if we use the newest technology and well-trained personnel to maintain the nuclear power stations, there shouldn't be a problem. We believe that the advantages of nuclear energy are more than the disadvantages.